everyone. We meet again in the Polish astrobiology panel discussion. If you would like to see more of our previous discussions, you can find them on YouTube, looking for PT Astrobio. This time we have a special occasion because the panel is a part of a bigger initiative, the World Space Week. And the World Space Week is an international celebration of science and technology. This celebration takes place each year at the beginning of October. And during the World Space Week, space agencies, aerospace companies, schools, planetaria, museums, and societies like ours meet to celebrate and talk about sustainable development of humanity. This year, the World Space Week is celebrating space and sustainability. And therefore, we have gathered for you an amazing group of scientists that deal with the space and this particular subject every day. But before we start, I'm going to ask each one of our panelists to introduce themselves and tell us a little bit about their work. I will start with Nicola. Hello.
Hello. So I'm Nicola. I work at the Space Research Center, Polish Academy of Sciences, as an astrophysicist, as well as in Cryotech Instruments as an AOCS engineer and mission planning. And I'm also a member of Polish Astrobiology Society.
Yes, you could have met Nicola on our previous panels. Could you extend the abbreviation that you mentioned so we understand more what's
so it's an attitude orbit control systems. So we design systems that help with orientation of the satellites in the space and orbit change, orbit control, etc.
That's wonderful. And that means that you are keeping the satellites on the orbit. Please keep doing so. All right. I'm going to go to Anna now. Anna, could you introduce yourself?
Yes, hello. I'm very happy to be invited to your discussion. I'm a space lawyer, I'm a space researcher, and I'm working in a Institute of Space of State of and Law of National Academy of Science of Ukraine, and also we have an International Space Center. I prepared my PhD thesis on the topic of protection of near-Earth space from space debris. So space debris is my passion to manage this issue. Also, I'm a member of International Institute of Space Law. We, with my colleagues, we try to prepare national and international documents which have the aim to manage the problem of the space debris and make something for making space more sustainable and more safety. So that's my work. Thank you.
Thank you. You said something very interesting, that you try to help protect near-Earth space from space debris. That means still within our atmosphere where the planes fly. What is this near-Earth space?
I can tell you only at the dimension of law because I'm a lawyer. So in the international law, we have not a very exact delimitation of space and air space, because we have two different suggestions from different states on the base of Committee of Peaceful Use of Outer Space, but there is some common suggestion of in the academia and from different states. For example, in the law of Australia, we have some regulation that prescribe that space it starts from the 400 kilometers. But there are a lot of different other suggestions, and we have not such regulation that can be sure it can be obligatory for all the states. So that's we have also another suggestions. It's so-called functional suggestions. And it's depend of what technical solution can suggest some is it satellite, or maybe it's suborbital techniques. So I cannot explain more. I think we have an expert here explain better, but it's like that now.
Yeah, maybe we'll get to this question later on, but it is a fascinating problem that we can't even determine where the space starts. And it's an interesting problem for law, as you mentioned. I will now ask Mariusz to introduce himself and tell us a little about your work, please.
Hi, hello everyone. My name is Mariusz. I am a space safety expert. I work at Sybilla Technologies. This is a company which is 100% dedicated to space observations. We use astronomical observatories across the world to actually track satellites and space debris, and to help space agencies like Polish Space Agency or European Space Agency for their space operations. So we provide both hardware, software solutions, and the data so that they can track satellites better, and, for example, to avoid collisions with space debris. That's what we do every day. And I'm happy if there will be a question regarding space safety scenarios or space debris in a more practical way.
Yeah, as you see, we have a very diverse group of specialists. Every of these jobs is so important for sustainability. But what actually the sustainability in space means for you? And let's go around the table again. And Nicola, how do you understand the sustainability in space?
So I see it as a way of making sure that we are safe to send more instruments to space, that we don't interact with other objects that are already there, that we have safe ways to mitigate and make a re-entry of our current satellites possible, and in order not to make more space debris, as Mariusz mentioned before, and how to be safe on Earth and also be safe in the space while we explore it.
This reminds me of a problem that I heard once, that if we have too many objects on the orbit, we can create something like an artificial cage around the Earth, so we wouldn't be able to leave anymore. And how close are we to this problem?
I mean, there are a lot of space debris there. If you even go to Google right now and type space debris, you can see Earth surrounded by this huge amount of small and not so small objects that kind of cover Earth like a shell. And it's actually the problem that it's not only that we shouldn't send more satellites into the space in order to stop this, it's already increasing exponentially, even if we don't send anything more there. So we have to come up with some mitigation techniques to clear the space a little. And it's currently what many companies are doing.
This is terrifying. And your work is so important. Thank you so much. And Anna, what do you understand by space, sustainability in space?
First of all, as a lawyer, I can use the explanation, the term which was subscribed at such a document as a guidelines for long-term sustainability of outer space activities. And there is, we can find a very long term of long-term sustainability, but short, its content we can understand as ability to maintain, conduct space activity for future and generations, and also to preserve the space environment for present and future generations. For me, space sustainability is about ability to make to gain the services, space services constantly, without any terms, and also it's about preserving environment, because for me it's extremely important to recognize space as well as environment, as our climate and all that we have ability to recognize as environment. So space is like environment as ocean and forest and so on, like that. Yes.
I couldn't agree more. And being an astrobiologist, I always see Earth as a part of a bigger picture. We're just one small planet, but there is so much more to explore. And with your work, maybe we will be able to do it much longer than this terrifying vision of locking ourselves out on this planet and not being able to go outside and explore other worlds. Also, we all know that any development in space brings back discoveries to improve our well-being here on Earth. So treating space as a part of our Earth environment is also an incredible thing to do. And you also mentioned another term, outer space. So we have both space and outer space. We'll be discussing that pretty soon, I'm sure. Okay, and I will go now to Mariusz and ask him to tell us, what do you think about space and sustainability? How do you understand that?
I can agree that we should treat space as a part of the Earth, because we really rely in our daily lives on space infrastructure. So keeping this things flying around the Earth safe, and which gives us data, navigation, weather forecast, and so on. It's really crucial for the Earth, for our lives on the Earth. So we should treat it. And I like this comparison that this near space is kind of a resource, which is limited resource, and we have to keep track on it, and we have to keep eye on it, and make it not clutter it enough so that the future generations could not make use of it. So this is the main point of all of the space safety operations right now, to not being locked in near Earth space, let's say. We call it the Kessler syndrome, so that we cannot launch anything more to space, because it will be immediately destroyed by some flying space debris. And each and every day we have more and more stuff flying in space, like the Starlink satellite. Starlink constellation is growing every second week, and there will be more constellations flying around Earth, because people want the internet on the ground every day, everywhere. So this is how space is really connected with us, or we are connected to space, and we should keep we should treat it, in my opinion, like a fresh air or fresh water. It's really limited, and it's really crucial for Earth, for ground operations, and for future generations to come.
Thank you so much. I mean, yeah, I never thought about space as an actual resource, but yes, taking under account that we use cell phones, and as you mentioned, like internet is going to be maybe soon distributed from space. I think it's already happening, right? Not sure how available this technology is. Is it already worldwide available internet if you need it?
Definitely, it's not really worldwide. If we think about Starlink constellations, we all know about situation in Ukraine, where Starlink terminals are helping soldiers to fight. But if in more peaceful scenarios, Starlink or similar internet providing constellations will give access into the internet for people living in some rural areas, let's say some remote areas, because we have broadband internet in large cities and in smaller cities as well. But when you go to some sort of let's say maybe to Chile, to Argentina, maybe to South Africa, things, or even the parts of Australia, you can maybe this kind of satellite internet will be the only way to communicate. And this is years ago. It was with cell phones. They were really expensive. Nowadays, everyone has internet in their cell phone. Maybe in 5 or give it or take it, maybe 5 or 10 years, satellite internet will be something which is obvious to have. We don't know that, but this is we can easily assume that this will be the case because internet connectivity. And if you imagine that years ago it was assumed that about 70% of mobile applications actually depends on satellite data. I mean, it is navigation, weather forecast, some satellite imagery, and so on. So 70% of Earth-based businesses rely on satellite data and rely on the internet, because without the internet you cannot provide data to consumers, to your clients. So this this interconnection between space infrastructure and ground infrastructure and all of us is really tightening up. We cannot let's say we cannot escape it or easily remove the space infrastructure and forget about it right now.
It is an astonishing number and such an easy answer to any skeptic that says, why do we even fly to space? 70% of businesses being dependent on what is already on the orbit. So pretty interesting. 70% of applications, as you said, depend on satellite data. Also, I always admire this kind of a jump in development where maybe, as you mentioned, in some countries in Africa, they will not even have to build a ground-based infrastructure. They're already going to depend on a space internet. And something interesting that you mentioned, that there are going to be like internet providing constellations. What do you understand by that?
It's like Starlink. It's all about Starlink and similar constellations like OneWeb. Well, Starlink is growing rapidly. It's the most advanced satellite constellation right now, but there are others which will start to compete, like OneWeb, some Arabian satellites in the future, because maybe Chinese constellations, we cannot right now know what Chinese is planning, because they keep everything in a very, very secret. But just imagine, there is not only one GPS constellation providing navigation. There is obviously the US GPS. There is the Galileo system, the European system. There is a Chinese system, Japanese system. There is Russian system, or there was Russian system. Let's say let me say it right this way. And even India wants to also have their own satellite navigation. So you have multiple constellations providing navigation data, and there will be exactly the same with internet providers.
And I understand that by constellation you mean an equally distributed satellites in different spots, but also the Starlink. I think I've seen, looking at the sky, dark sky, I could see several satellites, one after another, passing. That is something new to see. And also, I don't know if any of you heard is it a gossip or not that actually the amount of light that these constellations generate might interfere with our observation of a deep space? That's a thought that the maybe some observatories actually suffer from having too much on the way.
It is a problem. The light emitted from different satellites and instruments actually can interfere with the optics of other instruments. So there are active projects, for example, in ESA, to control the light pollution in space in order to keep our observations clean, let's say. One of the reasons is that.
So we're not only building a cage around ourselves, but we also making ourselves blind to what is outside. That is a really disturbing thought. So I think we very deeply answered already the question, why do we need clean space? Now let's talk about what we can do to keep it clean. I have several questions about that. For example, first of all, how do we track the things on the orbit? How is it done? How do we make sure that we're not generating more? And yeah, also the question, maybe I should start, why are we discussing it now? Is this became a serious problem over the last 10 years, 5 years? Nicola.
I mean, it is a constantly growing problem. Like I said, we cannot even send, I mean, even if we did stop sending instruments to space, satellites, the debris, the amount of the debris will still increase, even exponentially. I mean, most space debris is generated from breakups, collision, like solid rocket motor firings or ejectas, or, reactor coolant releases. And there are many technologies. I mean, I think there are three main technology areas that can help with that. Is the orbit systems, design for demise, and passivation. So like Anna probably can tell you much more about it. There are some regulations, but they're not very strict. From what I can understand, there's like an old law about it and some guidelines that we can follow through. But we definitely have guidelines about like on-ground risk assessment. And from what I know, every satellite that is sent to space right now has to have a re-entry or a safety passivation systems for tanks and batteries. And this is all we have to do, because light pollution, because space debris, like we said, it's a resource and it has to be maintained, and it's running thin. So we have to take care of that. And there are a lot of ways to do so. I think on-ground risk assessment and active removal of space debris is in order, even if we don't send anything else there.
I will ask you one more question, and then I will go to Anna to ask about regulations. How do we? Are there any regulations to prevent generating more space debris? But Nicola, you touched on a very interesting subject that I wasn't aware before. Like, what actually is the space debris and how many ways you can generate it? You briefly mentioned ejecta, fuel release. Could you just spend a little bit more time explaining how the debris, how the trash in space is made?
Right. So, like I said, it's mainly generated by the breakups. I mean, for example, when satellites break down and collisions, I mean, major recent events actually dominate the current environment. I mean, the debris that came from these major events, like the Fengyun 1C, I think, interception in 2007. Anna is nodding her head, so it must be right. And the Iridium Cosmos collision in 2009, and Russian ASAT in November 21st. So yeah, it's our problem, because can you imagine, we have, for example, United States and Russia, and so we have an alert in US that we're in the collision course with some other object in space. So we do some orbit control, changing the maneuver, the position of the satellite, and they get the same alert, so they do the same. And we don't have any laws that actually regulate and ensure that it's very well regulated. So we might actually end up in the situation when we collide, even though we both did what we had to do to prevent that. And it only causes more space debris. And as it circulates around the Earth, it collides and collides, and exponentially is growing the number of space debris. So it's kind of ironic, but we try. It's hard to control, so we have to have active, passivation systems and deorbiting and demise mechanism built.
This is, of course, fascinating and reminds me of sea law, when two ships are heading to each other and they communicate, and there is a certain regulations that allow them to pass and to avoid collision. But even if they collide, they simply sink. But what you said, whatever crashes in space stays there. It kind of multiplies, as I can understand that, and generates more debris that can cause more collision. Terrifying. I don't know if I want to go to space anymore. Anna, how do we prevent that? Like, what are the regulations? Like, what people should do when their collision alert comes, or what other kinds of regulations in general exists?
First of all, Tomasz, I ask you to stop me when I took a lot of time, because I can
Go ahead.
speak about it very long. First
So
of all, I want to add about space debris, because the term of space debris is also very important thing, because there are a lot of terms of space debris in a different document, and from the exact explanation of this term, it's depend how to do with this space debris. First of all, space debris lawyers have a very lot communication, and they think, is it space debris, is the part of space object or not? Maybe it's something like very different from this. If we understand space debris as a part of space objects, we can use the general regulation of Outer Space Treaty, Convention of the Registration, and the Convention of Liability. And this convention can help us to communicate when the risk of collision will be stand on the table for in the international communication, because how Nicola said, when we have a risk of collision, it's necessary to communicate different countries, because it could be recognized as an act of aggression also. Because some states like Russia, on the different forum connected with space sustainability, I mean COPUOS, and also in last year was elaborated new open-ended working group. That working group focused on elaboration of responsible behavior in space, and this regulation that will be prepared by this open-ended working group, they also examine this situation with collisions and very unsecure assessment and the risk of collision and so on. So we have such a diplomatic problem, because we have not a very clear procedure of communication between states. The second one, we have a lot of non-obligatory, mandatory regulation. I mean, some resolutions of United Nations. For example, we have a guidelines for mitigating of space debris. This guidelines was elaborated at 2007. Also, more technically all the time interagency working group also elaborated and updated these regulations. Also, we have the space system guidelines of long-term sustainability that was mentioned. Here, we also have some regulations connected with the plans of mitigation of space debris and so on. I can mention that each state have some progress with to combat this problem, because we have a lot of states that implement this non-obligatory rules into the national legislation. So it's became necessary to realize this regulation and so on. But we have two huge types to combat the space debris. First of all, it's mitigation, passive actions, but the second one is the active space debris removal. And this is very different type, because when we talk about active space debris removal, it's connected with with the problem which I start. It's communication between states and to recognize this active debris removal as a peaceful act, but not the act of aggression. And I was very happy when I recognized that United States one of the senator suggests the Orbit project. It's a bill. This bill prescribed to make a list of space debris most harmful, that can be most harmful for outer space and also for our environment. After that, to make some demonstration and to help private companies to elaborate some actions to this active debris removal project. And after that, demonstration, suggest how to make better legislation connected with active debris removal. For me, it's a very great initiative, and if each state can provide, can take to their practice also this initiative, it will be great for our for environment of outer space. I stop this.
So good to hear that you seem to be very excited, and I trust you as a specialist, and I can hear that you have a lot of care about Earth. So it's very good to hear from you that there is some, a positive outcome of those regulations coming in. And could you tell me, for example, you mentioned guidance like by UN. Is there any way to enforce them? Like how are they enforced? Like how do you make sure that people align to them?
It's the only one really effective way for enforce it. It's implemented to the national legislation and to make this legislation more common for all states. And great that new space actors, when they elaborate their legislation, they take into account this, because the space actors which had their legislation, they think about maybe we can implement, maybe not. But when some state try to elaborate to communicate with other state, when the state try to make some legislation, they start from this problem. I think that it's great and for better communication and for make this regulation more common, because it's the question of justice, because some states think why we should do this something for our outer space. We did not make something for create space debris. I think it's not a very good idea, because common space is the common for all of state. So each state should make something that he can for combating this problem.
Thank you so much. In the meantime, you did mention active and passive removal of debris. I will ask that question a little bit later to Nicola, but first, Mariusz, we talked about how much debris there is on the orbit, and I know that you are working with something that is called traffic management. Does it mean that you know something about the ways how to track debris and how the alerts are, going off that something is coming? I don't know. Tell us a little bit more about traffic management.
Well, space traffic management is kind of a, let's say, prototype activities right now, because we are facing as nations, as space operators, let's say like space agencies, that we have a lot of more traffic in space than it was 10 years ago, for example. So no one is really having a 100% implemented space traffic management. It's still on side of space agencies tracking their satellites and then trying, for example, communicate with each other that they have to do maneuvers. Like European Space Agency has to do maneuvers, and there was an example when actually Starlink satellite was on a collision course with a European satellite, and it was the European Space Agency who did the maneuver to save both assets. But there was a misinformation and miscommunication between the two entities. So for the space traffic management, we need to develop, first of all, a global network of observatories of different types. If you think about the astronomical observatory, so it's an optical observatory, but dedicated to track satellites, to photograph sky, just to these satellites in the images or space debris. But there also, we need a global network of radars and laser stations that will help, all of these operations. Then, if you have this ground network of observatories and you can gather the data, then you have to process the data efficiently. Sometimes even within the 12 or 24-hour time frame, because this information is crucial for space operators like European Space Agency, or other or American agency, for example, or national other agencies, so that they have time to prepare maneuvers. Because sometimes it is, you have not, you don't have, you cannot plan a maneuver of a single satellite in such cluttered environment within hours. It usually takes a week or two, at least. At least the information I have from European Space Agency. So they work weeks before actually conducting a maneuver in space, because they have to compute all of the consequences of their maneuver. So how this new orbit will influence other traffic in space. So this stuff is really, it's becoming really complicated, especially on low Earth orbit, which is the most precious resource of space we have, because most of the satellites which are giving the data to people on the ground are located on low Earth orbit. It's like forecast. It's like satellite imaginary for agriculture, for forestry, for air traffic, and so on. And or Starlink satellites, they are flying in low Earth orbit. Let's say it's 1,500 kilometers, something like that, or something in between. I can't remember right now, but yeah, this is still low Earth orbit, and it is really, we have a traffic jam now. Or if we don't have it now, we will have it in 5 years' time. And so we need data. We need to process it really, really efficiently, really fast, and to pass the data to space operators. It's even not that easy on paper, to connect all of the dots for the successful maneuver of a satellite in space. But it's and space agencies cannot do it on their own because of different reasons. So for example, American Space Agency, NASA, they are fully public agency. European Space Agency operates on different terms. It's connected with it's built on agencies which are on national agencies which communicate with each other. Let's say it's a hub for European agencies. There are small national agencies which operate on their own, and they all have to communicate globally. If as Anna mentioned, if there is two nations, two states, two agencies which are preparing a maneuver, and they actually can collide because they don't communicate with each other, and we will have all bad times, in terms of space. Here. So this is so what we do. So what's practically done on Earth right now? It's, let's say, I would say prototype operations at this level, because we have ground networks of telescopes. For example, Poland has the biggest European assets of telescopes. So not only our company, but there are other companies and institutes in Poland that possess observatories which are dedicated for space safety operations. So we deliver data both to European Space Agency, Polish Space Agency, European Space Surveillance and Tracking Consortium that tries to save, or so it tries to save at least the European assets. So we know the positions, or people working in operating centers, they gather our data and they process them for their operations. So we give them positions of satellites in images, and they do whatever they need to do later on to keep their satellites safe in orbit. So we are working on a really a very basic level, just where the satellite is in orbit, and we give you those data, so you can make the satellite working in orbit later on. So that's let's say we are at the very, very ground level here. This traffic, it will have to there have to be developed a global network of different types of ground stations, and that shares data between each other and between agencies, between states, so that this is like let's imagine like air traffic control in a very similar way.
Yes, you started answering the question, what can we do? And it seems like it's going to be a multinational, complicated network building project that is going to probably take years. And you said, like, just in 5 years, we might have a traffic. And also, as you mentioned, the traffic jam with the complex maneuvering that takes about a week to avoid collision. So that seems like a
Yes, just to see the scale, but I can recall one Polish example when we were, where Polish Space Agency was, let's say, waken up during Christmas, and we have a bright satellite, from a satellite, a CubeSat, scientific CubeSat with no propulsion on board, so it's so it cannot be maneuvered at all. Its orbit, and there was a close passing by a rocket body, and just imagine that the distance at the passing was 4.5 meters, and it could just lead to a disaster for a Polish asset. 4.5 meters. So just imagine that you have and there were cases, we heard today that there were collisions of a Chinese satellite, but there was also a case that the operators didn't do anything because they calculated that they will have 50 meters of passing between of the distance between two satellites, and they collided. So you have to have precise data from the ground or from space-based observatories, because it is also
Yeah, but also you say that there could be CubeSats. They're so tiny, and tracking this, it's incredible that we even can do that. But the question is, from me, is because you said like it missed it for meters, right? And how is it possible? Like in my imagination, there is so much space. There is a reason why we call it space, right? So is the space not so spacious anymore? And is it because we put everything on the same height? Can we just make, if we have a lower orbit, can we make like a semi-lower orbit a little bit higher, and then everything goes above each other? Or is it because they're like elliptical and they cross? How the collision happens, like if in such a spacious space?
The best example for this is geostationary orbit, where all of the satellites sit, let's say, at the very similar height above the Earth, and they are close to each other, and you have a special orbit, a cemetery orbit, 300 kilometers above. So when the satellite active satellite on geostationary orbit is taken out of duty, it is pushed 300 kilometers above, right? And it is, it's really cluttered because everyone is using satellite television and so on, and we rely on this or all satellites on this orbit. But when we have low Earth orbit and CubeSats, they are, and just imagine there isn't a situation where you launch a single CubeSat in space. You launch a pack of CubeSat, like pack of Starlinks, right? So they are flying one after another, to be honest. So this is basically the same orbit. And if there will be a collision on such an orbit, then obviously the first, let's say, few orbits, dozens of orbits, the debris will spread out more or less along the original orbit. But because of the atmosphere drag, because of the gravitation and so on and so forth, the orbits will spread everywhere. To be honest, that was the case for the Feng-Yung
Mm-hmm.
collision. So you can, and it will be random after years. So you cannot predict it, because the Earth atmosphere, especially at low Earth orbit altitudes, it's pushing it's pushing above satellites or dragging them down, and it's all connected with solar activity, right? Which you cannot control. You can observe it.
Right. Anna?
Only. We are not living in a very separate space.
Mm-hmm. Go ahead, Anna.
I want to add some 2 or 3 words about it. The problem also in each state or each region have its own proper system of surveillance, because we have a different system of surveillance. For example, the United States with other states have its proper system of surveillance. In the European region, we have another system of surveillance, and another thing. So we have a different system of surveillance, and there is some situation where the system of surveillance also have misconnections. The problem with it's emanated from the misconnections, because how was mentioned, there is some problems when Starlink have a very close proximity with the Chinese space station. It was a very tensive communication between operator of Starlink and the Chinese government, because there is some diplomatic notes which was sent on the level of General Assembly and so on. So the problem also once it's technically, but also it's the problem here arises from misconnection between these different systems. And also we know that only teeny, very small part of space debris, can make a very huge harm, because it can destroy some solar panels and so on and so on. But we cannot survive such very teeny particles of space debris. I read about that. Maybe experts may add something more about this, because I'm just a lawyer. So I see this problem in this.
Well, I'm no expert, but I can definitely stand behind your statement that we catalog objects, like you said, with the space surveillance systems. We have radars, we have optics, and there are some objects that are cataloged and those that are not cataloged. And some we follow constantly, and some we are trying to catalog, on the way. And yes, there are objects, even 1 millimeter object can actually interfere with equipment in space. So you can imagine 1 millimeter, it cannot destroy it, but it can, if it's like 5 millimeters, 10 millimeters, it could actually penetrate the tank. So it can be dangerous.
So it seems if you have some of the objects that can be tracked and some that are not even annotated, can you see the collision after the annotated one just moved and you assume, oh, there was a collision? Okay, and how, Nicola, how much time do we have, like when the alarm, when we get an alarm, there is a collision course, how much time ahead do we get to act if something like that
I'm not really sure. I suppose it's not a lot of time, but what we mostly do is we try to simulate it before. So every object that is sent to space, every satellite, we have some simulations in the process of mission planning when we try to simulate what is the lifetime, what will the orbit change and etc. look like. When we have, our fuel, it only lasts for amount of time. So now we also have some, like Anna mentioned, passive and active ways of mitigating those satellites.
Please elaborate on that. I'd like to learn more after you finish your thought.
So I'm not really sure what is the time after you get the alert, but maybe Mariusz can add something about it. I think he would know. Do you know, Mariusz? Because you're dealing with the traffic, right?
I'm no space operator, to be honest, but I can. Yeah, well, for let's say for ground stations to deliver the data, we try to do it in 12 hours, let's say, or in 24 hours. It might be too late for space operators to get this data right.
That gives us a perspective, but
it takes 2 weeks to a week or so.
All right. So we are almost at the hour of our discussion. I still have questions for Nicola about the passive and the active removal. And I know that I think you take part in the design of a mission that is going to be collecting debris from space. Is that correct?
No, I don't take part in that. We discussed it at some point, but I don't take part. I do take part in the construction of like microsatellites and CubeSats, etc. And we deal with mission planning, but we did talk about it. And there is an active project that will be launched in 2025, I guess. It's Clear Space One. It will actively remove space debris from space environment. So yeah, this is what we discussed. This is what you remember.
And what would be the approach for active collecting of debris? Like I did see a few of possible examples, like a net, like an active, just some holder, or what are the options here?
I mean, I do know about the arm, so we have to align our velocity with the velocity of the space debris, because there are high velocities. It's not just like you can like walk up to it and then just grab it. You have to equal the velocities that you both have and the momenta, so you can grab it without harming it. Because imagine if you collide with high velocity with the object with a high velocity, you just crash and make other debris, which is not helpful. But asking about the active debris removal is designed for demise. I think this is how it's called. So it includes like critical elements like tanks, large mechanism, and AOCS actuators, and some elements. So like Mariusz said, there are some CubeSat that do not actually have a propulsion system. So we have to make them deorbit themselves after the end of their mission, let's say. So for example, 5-8 years, they will reach so low orbit, low orbit that they will just burn in the atmosphere. But we have to kind of make sure that all the necessary elements are pacified, like batteries or some propulsion, so it doesn't burst into flames or somewhere. Risk assessment, like on-ground assessment, is the other thing, but passivation is entirely something different. And there are also re-entry mechanism. We can create small explosions, so the satellite will fall apart into smaller pieces, so it will burn in the atmosphere, which it wouldn't happen if it was still assembled in space. And there are actually many softwares. I know of 2 that ESA uses, but probably there are much more, where you have your satellite, you set its course, they're already uploaded, all of the cataloged objects we have in space, they're uploaded there, and this is refreshed and refreshed as we catalog them more. So we can kind of create the scenario, how it will deorbit, what is the risk assessment for the casualties and on the ground, etc. So there are a lot of ways to do that. And I think it's all in the guidelines that everyone should do that. It's not strictly legally regulated, but it's advised, and how it goes.
We got some questions from the chat, and what you just said, I think, answers the first question, that was, are there any currently tested or maybe used technologies that help with getting rid of space debris in large amounts? And what I understand, it's mostly large amount is preventing deorbiting, right? And then, the debris that is already there, it's a bigger of a challenge. You also mentioned something interesting, that someone can actually be hit with the part that falls from space, and that's actually not a zero risk.
But it's very relatively small, because for a small spacecraft around, let's say, 700 kilograms, I think the casualty risk on ground is less, like 10 to -4 or something. So it's very low. There's a higher probability that the random track will hit you than some space debris, falling from the sky. So it's not something that we should be really concerned about on a daily basis.
Yes, I even checked recently that a probability to die in a plane crash is like 1 to 24 million. So not really a big chance. Okay. And then another question that we got, and I encourage everyone who's listening to add questions to the chat. We will be slowly wrapping up our meeting today. And the other question that we got is, how will the ability to process space resources and reuse space debris impact space sustainability in the long term? That means, can we reuse things that already are there? Like, can you just go collect and bring it back safely? That's what I understand from this question, but maybe you have other interpretations. Who would like to answer? Is there anything happening in this subject of trying to reuse whatever is, or is it all one use? That's it, forget about it?
I would say we need a space factory of some kind in orbit, which will be collecting large debris and disassembling defunct satellites. Because right now, as Nicola said, we have to safely re-enter orbit, satellites on low Earth orbit, because it takes 25 years for natural re-entry on up to 500 kilometers in altitude, and higher altitudes, you cannot rely on natural mechanisms to re-entry. For re-entry, you have to grab the satellite. like think of Hubble telescope. It's a piece of software, piece of hardware that will have to be somehow taken back to Earth at the end of its life. You cannot easily re-enter International Space Station. You have to disassemble it first, and then piece by piece re-enter into the Earth's atmosphere, and it has to be done in a very safe way. So I would say that, because then the risk of being hit by space debris will increase if we do it in a very unresponsible way. So for me, it's kind of a futuristic space factory. Another space station that's it's grabbing all of this stuff and make it reusable. But there's this Clean Space initiative of European Space Agency. But I encourage you to check it on European Space Agency website. What's Clean Space about? It's kind of a recycling all of this stuff. But again, I'm not that expert in hardware and space and space flying hardware, so I will rather guide you to European Space Agency website for that.
Mm-hmm. And on that, Anna, you want to comment?
Yes, I have a little comment. I read a lot that some space agency makes some assessment about space on orbit servicing, and for example, it's not space agency, but it's also a governmental organ, DARPA. It have some projects about that. After that, some private companies also try to make assessment. Is it maybe maybe economically reasonable, and I think that this law, that it's not law, it's a project of law that I mentioned, Orbit law project that will suggested by American senators. I think it's the first step for make some on-orbit servicing, because in this law, it's not only about active debris removal, but also about remediation of space objects that which lose their utility, and they cannot be maneuvered. Cannot be operated. So I think that first steps in the governmental level it's made, and also as a lawyer, I think about safety access to this space object, because it's the matter of to avoid space war, because as I mentioned, it can be some states can understand such actions as aggression, and the second one, it's the matter of ownership, because each satellite and each part of satellites can be some property of one of state or one company, but other state or other company cannot be very happy that such on orbit servicing can be made with that. So for me, it's the problem also here. But frankly saying, I hope that it will be in the near future.
Also, Mariusz, when you mentioned that this International Space Station has to be carefully brought back to Earth, an idea came to me, and maybe you guys will be able to answer. Couldn't we push it the other way and toward the sun? Is it even feasible?
I think it would take too much propulsion, and it wouldn't, be efficient to do so. It's more efficient to deorbit things and make the atmosphere help us in burning it than to actually push it back.
Okay, thank you. And we have a question to everyone. We will go around the table also. So try to answer the question we just got from a chat. Do you guys thought about flying to space? Is this something you are interested in? and we will go Nicola, Anna, and Mariusz, but also please add any other subjects that you think we should have mentioned, but we haven't yet in this discussion. So first of all, Nicola, would you fly to space, and why?
I mean, I wouldn't, probably. Not right now, at least. I mean, I like to investigate it. I like to look to the data from the telescopes and simulate stuff. It would be probably very cool to see what is happening, like, see the sunset from the ISS or something. But I think I would be very freaked out being in space, looking through the window, and the distances are huge. So when we say it's like a big shell and it's not empty, sure, it's not, but you probably seen some images from the space. It's still kind of terrifying. The environment is really harsh on the astronaut, on the astronauts, etc. I mean, doing the microgravity experiments would be like amazing to do and see it for once. But until we have like cryo, places so you can freeze yourself and then wake up at another exoplanet, then I'm good here. So.
Thank you. Anything that you would like to add to the discussion that we had so far?
I think we touched the basics. Yeah, most of it. The most amazing thing for me is that we still don't have very well-regulated law, as Anna is keep mentioning. It's ridiculous because it's space. It's a resource, like we mentioned, and it's very important, and it can cause a war in space, and it could kill us at some point. And I think the reason for it is, so imagine now every country gathering to create new space law, and every country wanting to kind of put under the table their own legislation about some stuff and their own saying in the matter. And the larger the country, the more powerful, the more say it would have in it. So I understand why it's hard to make such legal changes.
I see. Anna, would you fly to space?
I agree with Nicola. No, I know a little. Very lot about unsafety in space, so I don't want to go there. Maybe after when we make something with this problem of space debris and other thing, and there. Yes, but now no. And what about elaboration of space law? I think we have a great political tension now. It's I can compare this political tension with that we had when first conventions was elaborated, because now we have a tension between China and USA and other states, and so a lot of problems in space became more harmful and more strict now. And I have a hope that elaboration of space regulation became more efficiently. And what we did not mention, I think, first of all, I want to say you thank you, a great thank you, because it's very interesting to see this problem from different point of view. And I think I want to ask you to make one more these discussions, because we cannot take all these in particular things in 1 hour, and I think a lot of interesting topics we can catch in the domain of space resource extraction and so on. So thank you once again, and I hope to have such discussion like this in the future also. Thank you.
Thank you so much. We'll definitely look into it so we can organize more discussions like that. The subject is incredibly complex and important. Mariusz, let us know, would you fly to space, and anything else you would add to the discussion so far? I'm afraid one of the satellites failed and Mariusz is temporarily frozen. We'll see when he comes back. We also got another question from chat that is right now on the screen. Is there a realistic possibility to hijack a satellite? Are they seriously protected from possibility hackers, or there is no real need for that? Like, can someone take over a satellite? Who would like to answer?
Yes, sure, it's possible, and I know that there are some examples with hijacking of satellites. It's depend of hijacking because we have a hijack of control over the satellite and also to transmit the data from from the satellites. About the data, it's more. It's more. We have more examples about hijack of a satellite. It's more complicated, but it's also can be happened. And I know that. Once again, in the USA, we have a policy about protecting the satellites from the hijacking. I know that such state like Israel and such other states, I should think about that. They also suggest some regulation, but the problem is that internet is very non-regulated domain, and there are a lot of problems with the identification of the subject of the actors who made it. So like that.
I see. Mariusz, back to you. Would you fly to space, and anything else you would add to our discussion so far?
Well, I would like to fly to space. It's actually the reason I work in space industry, and that's why I graduated in astronomy at Nicolaus Copernicus University, because there was no astronautics in Poland at that time. Yeah, so I would fly to space either. Nevertheless, it's dangerous. It's freaking out people and so on, and you can be hit by space debris in your window, let's say, of your spaceship. But what's interesting maybe to add is that we talk about space around Earth as a resource, but I would like to mention that we already have 200 or more space debris flying around the moon, and we are going to the moon, and we will have more debris flying around the moon, and there will be exactly the same problems we have right now on Earth in the 20-year time frame, something like that, because there is already a plan. Everyone heard about the Artemis mission and bringing back people to the moon. And with people being back on the moon, we will have all of our issues from the Earth bring back to the moon, and all of this connectivity, having internet on the moon, having satellite navigation on the moon, and so on and so forth. So all of this stuff, will be just copied from Earth to the moon in let's say, a decade or so. So
wherever
keep in mind.
Wherever we go, we take our problems with us. Of course, I'm thinking already about Mars. There's few satellites on the orbit too. Europa Clipper is gonna soon gonna be around Europa. We're gonna generate debris there too at some point. Okay, thank you so much. We are wrapping up this session. I think it was very interesting. There was a lot to discuss, and as Anna mentioned, we should definitely continue talking, because that's how we solve the problems. I personally see this challenge as a great test for humanity. Either we will become a one nation on Earth and create legislations that will allow everyone to safely explore space, or we fail the test and we just stay here forever. So hopefully we'll manage to make the first one. So thank you so much. And we'll see each other on our next panel sessions. I think the World Space Week is an incredible opportunity to make this kind of meetings. And we want to thank all the organizers and everyone in the back from the Polish Astrobiology Society that also helped organize it. If you would like to see more content, we have a Polish Astrobiology Society website, AstroBio.pl. You can find us on Facebook, on YouTube. PT Astrobio on YouTube is what you want to put to see it. Thank you so much, and have a great night.
Thank you. Bye.
Yes, thanks a lot.
Bye.
Bye.